Y'all, today we're going to be talking about section 1.2 from the textbook, displaying quantitative data with graphs. So we have several types of graphs that we're going to use when we're talking about quantitative data. So when we see the word quantitative, quantitative is like quantity. So it involves numbers. All right, so it involves numbers as data instead of categories as data. Okay. So we have a couple different types of graphs for this. One is called a stem plot. This is also called a stem and leaf plot. All right, they work best for small numbers of observations that are greater than zero. By making a stem plot and turning it on its side, it gives you a quick picture of the shape of the distribution while including the actual numerical values. Okay. It says when you wish to compare two related distributions, a back-to-back stem plot with a common stems are useful. And another type of quantitative graph is called a histogram. It's basically like a bar graph, but with numbers on the bottom instead of categories. And that shows the distributions of counts or percents among the values of a single quantitative variable. Some rules for making histograms: the classes or the bins or the bars need to be of equal width. And a good rule when you're making a histogram by hand is to use a minimum of 5 classes, okay, or 5 bins. Be sure to pay attention to whether you're reading or creating a frequency histogram or a percent histogram. And a dot plot is one of the simplest ways to graphically represent quantitative data. So let's look at some of these problems. The best way to understand this is to do problems. So example 1 says smartphone battery life. Here is the estimated battery life for each of 9 different smartphones in minutes. Make a dot plot of the data and describe what you see. So let's look for which one of these have the minimum value. To me, the smallest value is 300, okay, and the biggest value is 460. So if I'm going to make a dot plot, I'm going to put a line, okay. I'm going to give it a title, so we can call this battery life among 9 types of smartphones. Okay. Down at the bottom here, I'm going to give this axis a label, and we're going to call that minutes. Okay. And the smallest one is 300, so I need to get 300 in there, and the biggest one is 460. All right, so maybe I'll just write 475. All right, and then we can equally space. Maybe we want to do tick marks every 25. Okay. So let me make this a little bit easier. Instead of stopping at 475, I'm going to stop at 500. So right in the middle would be 400. All right, and we can further subdivide that into halves, and we can go 350 and 450 about right there. Okay, and then I can put minor tick marks in here, which would represent 25s. Okay. All right, so Apple iPhone has 300 minutes, so I'm going to put a dot there. That's why this is called a dot plot. All right, I took care of that one. All right, Palm Pre is also 300. I'm going to find all the smallest ones first. So I got 300, I got 300, and I got the BlackBerry Tour has 300. Okay, so I took care of those. Now I'm going to find the next smallest one. I see the BlackBerry Storm has 330. That would be about right here. Samsung Moment is 330. I should keep these dots even, so let me scratch that one out. Okay. Should keep the dots roughly starting in the same spot. Okay. All right, let's see, what's the next smallest one? I got a couple that are 360. So 360 and 360. That would be about maybe right here-ish. I have one that's 385, so there's 375, so 385 would be about right there. It's the Motorola Droid. And then I have the last one, the HTC Droid at 460. That's about right there. All right, so just to make sure we got them all, said we had 9 different types, so I should have 9 dots down here. 1, 2, 3, 4, 5, 6, 7, 8, 9. Now ask me to describe what I see. Okay, so if I'm just looking at these dots, most of the data is really close to here in the first, kind of over this range. So to me, it looks like the distribution is skewed to the right. Looks like it has a tail coming off to the right. All right. We should talk about where roughly the center is. Okay. In this case, I'm going to talk about median. All right. So what's the middle data value? So if there's 9 data values, if I want 4 below and 4 above, then the 5th point is the median. 1, 2, 3, 4, 5. So the median is about 330 minutes. Okay. If I want to talk about a spread, or if I want to talk about a range, that's the biggest or the max minus the min. So the biggest is 460, the smallest is 300. So we have a spread of 160 minutes. All right. Then I might want to talk about outliers. Most of the data here is rather condensed between 300 and 385. To me, it seems like this one point right here might be an outlier. So the outlier is possibly the HTC Droid at 460 minutes. So that's a way I can describe a distribution. Okay. So if you think about it, I'm talking about shape, I'm talking about center, I'm talking about spread, and I'm talking about unusual stuff that I might see. So whenever you describe a distribution, the easiest way to remember to know what to do, we use the acronym CUS. Talk about the center, talk about unusual features, talk about the shape, and talk about the spread. All right. So the next question here says, here's some data on time spent on the internet. So they took a sample of some people. It says graph the data using a histogram. Okay. So if I want to graph the data using a histogram, all right. First thing we want to do is we want to get a good number of bins. We want to get a good number of bins. People spent as little as 0 minutes on the internet, up to as many as 360 minutes on the internet. Okay, now it doesn't tell us like if that's per day. I would assume it's probably per day. But we need to set a bin size. Okay, we need to set a bin size. And to me, so this is the biggest, 360 is the maximum, and 0 is the minimum. All right. Usually at least 5 bins is good, but more can be more beneficial. More can be helpful. So in this particular case, I'm going to choose just to use 8 bins. And we'll see what the graph looks like. All right. So on this axis, I'm going to put time on the internet. In minutes. And on this axis, I'm going to put frequency. And after I do this by hand, I'm going to show you how to do it on the calculator as well. Okay. So I'm going to choose to make my bins, every tick mark, I'm going to let that be 50. So when I'm all done, I'll have 8 bins. And you'll see why here in a second. All right. So when we talk about frequency here, okay, for 0 to 50 minutes, that means from 0 up through 50 minutes, but not including 50 minutes. So we need to add those numbers together. Okay. So if I add these numbers together, 7, 8, 11, 18, 19, 20. There's 20 people that spend less than 50 minutes. All right. Now we're going to go from 50 all the way up to something less than 100. So these people would represent that bin. All right. So there would be 18 people there. All right. And then you're going from 100 to less than 150. So that would be this right here. Okay, so there's 14 people there. All right. And you're going from 150 to 200. So that's just going to compromise the 180-minute people. So there's 10 there. Now both of these data make it into the next bin. There's 11 people that are between 200 and 250. All right. This next one, just the 270 will go in the next bin, because my next bin is going to go up to 300, but it's not going to include 300. So there's just 2 there. All right. The 300 to 350 bin will just include that 300. There's 9 people. And then the last bin, between 350 and 400, there's 3 people that spend 360 minutes. So as I try to make tick marks up here on frequency, okay, the biggest of all these numbers is 20. So I need to make this go up to at least 20. Okay, so if I make that 20, maybe that's 10. Okay, that would be 15. That would be 5, 2, 3, 4, 6, 7, 8, 9, 11, 12, 13, 14, 15, 16, 17, 18, 15, 16, 17, 18, 19. All right. So when we make this histogram, all right, here's how we're going to do it. How many people spend between 0 and 50 minutes? Well, 20 do. So we're going to make a bar. How many people spend between 50 and 100 minutes? That's 18. Now on a histogram, the bars actually touch each other. Okay? In a bar graph, they do not. Okay. How many people spend between 100 and 150 minutes? That's 14. And sometimes what you'll notice in here, they'll actually give you the raw numbers. So there's 20 there, there's 18 there, there's 14 there. It's more descriptive. Okay. Then the next bin has 10, between 150 and 200 minutes. Okay. And the next bin is between 200 and 250. Both of these numbers are between 200 and 250. There's 11 people. between 250 and 300, there's 2 people. At exactly 300 minutes, which would go in the 300 to 350 bin, there's 9 people. And then in the last bin, there's going to be 3 people. This should have been a straight line. Sorry about that. Okay, and give it a title. Time spent on internet. Of sample participants. Okay, now this question is not asking me to describe this, but if you look at it, the shape, it looks like it's going down each time. So this would be a skewed right distribution. Okay, I'm not exactly sure where the median would be, but it's probably, the center would probably be somewhere in here or somewhere in here. Probably somewhere around 150 minutes would be the median. Okay, the average, the mean would probably be slightly higher. Okay, unusual features, I don't see any major outliers. Okay, spread, smallest of 0, biggest of 360. So there's actually a range of 360. Looking at this, if we just were given this instead of this, that the people could be up to 399 here, and the people could be at 0 here. So we wouldn't be able to tell the range if I just had the graph. But if I have the data, I can talk about the range. Now, the question is, can I do this on the calculator? Can I make a histogram on the calculator? And the answer is yes. So I'm going to go hit the Stat button, go to Edit, and I'm going to enter the time on the internet in list 1. So 0, 10, 20, 30, 40, 45, 60, 90, 120, 180, 210, 240, 270, 300, 360. What I'm doing after each time I'm typing in numbers is I'm hitting enter, and it takes me to the next row. Okay? And in list 2, I'm going to put the frequencies. Okay? So frequencies are 7, 1, 3, 7, 1, 1, 15, 3, 14, 10, 1, 10, 2, 9, 3. Now, quit out of there. Hit y equals. If you have anything in your y functions, just clear them out. Now hit second, and then in blue it says stat plot. That means statistics plot. Go in there and go to number 1. Turn that statistics plot on, and we want to make a histogram, which is the third option. So go to the third option and hit enter. Okay. Now they're asking me, where is your data? Where is the time on the internet? Which list is that in? That's in list 1. For our particular problem, we have frequencies as well. So if I didn't give you the frequencies, you would leave this as 1. But if you have a frequency column, then you need to put that into list 2, which we did. And now the easiest way to get a good histogram, you can make it whatever color you want. Okay? So as soon as you do that, to get the best picture, hit zoom and go down to number 9, which says zoom stat. Hit enter, and it's going to make a graph for us. Now the calculator, what the calculator has done, it's chosen the bin width for us based on the data that was given, the best way to display it, or what they think the best way to display it. I might have chosen a bin width. I chose a bin width of 50. Let's see what they chose. They happen to choose a bin width of, it looks like 51.42. Okay, it doesn't really make sense to have, to me it doesn't make sense to have a bin width of 51.42. So the way I can do this in the calculator after I do the zoom stat, I can go under window and I can change this a little bit. All right, I can change it a little bit. I can go under here and say, okay, make that 400 instead of 411. And then I can make each bin 50 by doing that. I can make it each bin 50. Now hit graph. It's going to change the graph. Now, if you look at this first bin, it says, all right, it's going to take everyone that spent between 0 to less than 50. And then it also tells me how many people meet that criteria. So 20 people spend between 0 and 50 minutes on the internet, not including 50. So now this graph matches my graph exactly. Okay, if you look side by side at them, okay, they're the same graphs. Okay, they're exactly the same graphs. So and I can toggle over on my calculator. It says n equals 20, then n equals 18, then 14, then 10, then 11, then 2, then 9, then 3. Calculator will help you. Okay. You are allowed to use your calculator on everything in statistics. All right. The next type of graph we talk about is a stem plot. Okay. So it says make a stem plot of the following test scores in Mrs. Bates' statistics class. Okay. So when you make a stem plot, okay, it's easiest if the data is in order from least to greatest. In this particular example, it is in order. Okay. So here's how this is going to work with a stem plot. You're going to have a tens digit and you're going to have a ones digit. So the person that did the worst, the person that had the worst test score got a 56. So the tens unit there is 5 and the ones unit is 6. The next person got a 58. But we're going to put the 8 next to the 6 because it still has a 5 as a tens unit. So we don't repeat tens units. Okay? Now, if we start at 5, we have to put 6 there, even if there's no one that scored in the 60s. And then we go into the 70s. Someone got a 73. Someone got a 75. 2 people got a 78. Now we do have to write 8 twice because it represents 2 different data values. Okay. Then we're in the 80s. Someone got an 80, 83, 2 people got an 84, 2 people got an 86, 87, 88, 89, 89, 89. All right. We would make 90s here. Someone got a 90, someone got a 91, someone got a 95, someone got a 97, someone got a 99. Now your ones on the leaf here, this is called a stem and leaf plot. A stem plot's called a stem and leaf plot as well. All right. The ones can always be just 1 digit, so we just look at the last digit. So if 0 is the ones unit here, the tens unit would be 10. All right, so we're going to put a 10 there, and there's only one person that got 100. Now the cool thing about a stem and leaf plot is if I were to turn this stem plot on its side, like here, what we actually have is think about the heights of these things as a histogram. So if you want to think about that, 2 people scored in the 50s. It's basically a bin width of 10 from 50 to 59. There's 2 people that got between 50 and 59. There's 4 people who scored in the 70s. There's a lot more people that scored in the 80s. Okay, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 10 people that scored in the 80s. There's 1, 2, 3, 4, 5 people that scored in the 90s, and there's one person that scored in the hundreds. So turning a stem plot on its side basically gives you the shape of the histogram. If I put all this data into my calculator, this would be the shape of the histogram, as long as I set my bins up for a size of 10. Okay. Now there is, just for credit on the AP test, we should give this a title. So we can call this test scores in Miss Bates' stats class. And we should also give some sort of key. So for example, 5, then we put a bar to represent the stem there. So this represents 57 test score. Okay. So 5, 7 would represent a 57% test score. All right, so we talked a little bit about this already on the first page, but when we talk about describing a distribution, we need to talk about where the center is, where we think the center is, any unusual features, shape, and spread. All right, so we use the acronym CUS. So we use the acronym CUS when we're asked to describe a distribution. Okay. To describe a distribution, a set of data values. All right, so when we describe a quantitative distribution. Now, when we talk about the shape, there's a couple things that we can describe it as. We can say it's skewed to the right or it's skewed to the left if the long tail is going that way. Okay. Or looking at this graph roughly, okay, let's look back at this graph. You see a kind of a big middle bar, then you see kind of go off a little bit here. There's 1, 2, 3, 4, 5, 6 to the left of that, 1, 2, 3, 4, 5, 6 to the right of that. I think this distribution is fairly symmetric. Okay, when I say symmetric, okay, kind of like it might have that type of shape, but basically what I'm looking for, can I draw a line and get pretty much things that are close to the same heights? Okay, if it's pretty close, then we say it's fairly symmetric. So it's asking me to go back and describe the shape of the graphs drawn in examples 1 and 2. So coming back here, I would say, look at the dots here. I say it's skewed right. Okay, I would say this is skewed right. On this one, I think it's skewed right. It looks like it's going down and it's making a tail. All right, think about this just kind of being a line. Kind of looks like the long tail is going off to the right. Like we talked about this one is probably fairly symmetric if I needed to describe it. So there's some other things that we can do. It says illustrate the shapes of the following distributions. So symmetric, it can be a lot of different shapes. Basically, can I draw a vertical line in there and is the left the same as the right? Is it a mirror image of itself? Yeah, so that could be a symmetric distribution. I could have something like this. That's actually a symmetric distribution. You can have something that looks like a bell curve, which we'll get into more. That's symmetric. You could have things that have multiple curves. Okay, something like that, but it does look symmetric. Basically, is the left a mirror image of the right, or pretty close? If it is, then it's fairly symmetric. All right. The distribution that's skewed right has a long tail going off to the right. So usually an example of this is basically people's incomes in the United States. You got a lot of people that fall between zero and maybe $100,000 a year, and you got a few superstars that make millions of dollars a year. So that doesn't go up very high. There's not very many of them. The distribution that's skewed left means the long tail is going towards the left. So maybe something that you can think of to remember that one is test scores. You got a few people that do very badly on tests, but most people score between 70 and 100. But you got a few people that don't study. Okay, so they get really low scores. All right. The next one says unimodal, which means one mode. What is a mode? A mode occurs most often. So it basically means there's one high point in the graph. There's one high point, such as a bell curve. Okay, there's one high point, that would be the mode. It's also symmetric, but that's a unimodal. There's one high point in the graph. Okay, or if you're looking at, a frequency distribution, and this is a single number and it's the biggest bar, then it's unimodal. Okay, because you got one high point. It's the most frequently occurring. Bimodal means two modes. So with a bimodal, you have two high points that are about the same height. Okay, so that would work even if one's slightly higher than the other one. All right, we still consider that bimodal. Okay, because it changes drastically. Okay. And the last one is uniform. Uniform just means the frequency never changes. It always stays the same. Okay, so that's an example of a uniform distribution. Nice even line straight across. So that's uniform. And that is going to do it for section 1.2. So thank you for watching.